Welcome everyone, we've got a past paper question on acids, bases and buffers taken from AQA Year 2 Paper 1 2017 question 2. Black text is the question, red text provides additional information, blue text is the answer. Some points may be highlighted during the description. You can pause the video at any time and attempt the question before the answer is revealed. Let's get started. Here's the question. This question is about acidic solutions. The acid dissociation constant Ka for ethanoic acid is given by the expression Ka is equal to the concentration of ethanoate ions multiplied by the concentration of protons divided by the concentration of ethanoic acid. The value of Ka for ethanoic acid is 1.74 times 10 to the minus 5 moles per decimeter cubed at 25 degrees Celsius. A buffer solution with a pH of 3.87 was prepared using ethanoic acid and sodium ethanoate. In the buffer solution, the concentration of ethanoate ions was 0.136 moles per decimeters cubed. Calculate the concentration of ethanoic acid in the buffer solution. Give your answer to three significant figures. Here I've left only the essential information required to answer this question. There are a few different types of acid calculation: strong acid, weak acid, Kw if hydroxide ions are in excess. You have to be able to identify the correct method to use. As a starting point, you need to know the different equations associated with this topic. Next, identify the variables that you are given as well as what you need to work out. This will get easier with practice. This is a buffer question. For 3 marks, it is essential to show you're working out clearly. From the pH, we can calculate the hydrogen ion concentration. Next, rearrange the Ka expression to make concentration of ethanoic acid the subject. Now we put the values into the expression to calculate the answer. Here's the next part of the question. In a different buffer solution, the concentration of ethanoic acid was 0.260 moles per decimeter cubed and the concentration of ethanoate ions was 0.121 moles per decimeter cubed. A 7.00 times 10 to the minus 3 mole sample of sodium hydroxide was added to 500 centimeters cubed of this buffer solution. Calculate the pH of the buffer solution after the sodium hydroxide was added. Give your answer to 2 decimal places. The value of Ka is equal to 1.74 times 10 to the minus 5 moles per decimeter cubed. So again, another buffer question. We can show the partial dissociation of the weak acid with this equilibrium expression. Next, work out the amount of ethanoic acid and ethanoate ions present before the addition of NaOH. When we add sodium hydroxide, hydroxide ions react with the ethanoic acid. Ethanoic acid is used up and ethanoate ions are produced. The amount of hydroxide ions added is the same as the amount of NaOH added. We can calculate the equilibrium amount of ethanoic acid by subtracting the amount of hydroxide added. We can calculate the equilibrium amount of ethanoate ions by adding the amount of hydroxide added. Rearrange the Ka expression to make hydrogen ion concentration the subject. Volumes cancel, so we can use amount in moles instead of concentration. Next, we use this equation to calculate pH. Don't forget to read the question. 2 decimal places are essential. Thanks for watching and take care.